and welcome to the next video on mathematical logic. Still doing propositional logic. Moving on to stating and proving the unique extension theorem. So we saw a little demonstration of this in just the basic introduction to truth assignments. And we kind of saw how if I took an atomic truth assignment, I could extend it to some truth assignment. And here what we're going to state and claim is for any atomic truth assignment, there always exists a unique extension to a truth assignment. We will build up, so for a given truth assignment, we will build a sequence of functions. We'll call them V sub n. So if V0 is the atomic truth assignment, we'll build a sequence of functions V sub n, n ranging from 0 to infinity, such that each one will be defined on cent n. So each next function just has a larger and larger domain. Each one will agree with all of the assignments made by the previous one, right? So if Vn is equal to, if n is equal to 1, then V1 is going to make all the same assignments that V0 makes on cent 0. It'll just make extra assignments as well. In the end, to actually arrive at a truth assignment, we will, in a sense, take the union over all of the Vn. The sense in which that's like a union will be that if you give any sentence theta, right? So take any sentence theta and we want to decide what the truth assignment assigns to theta, we can look at the complexity of theta, right? Take any, really you can take any, but why not go ahead and take the complexity of theta, right? Which is to say basically the first cent n such that theta occurs in cent n, and use V sub that, right? So if the complexity of our sentence theta is n, then we will use V sub n to determine the value that it gets under the assignment. So, as I remarked back here, the fact that the result here is some truth assignment is fairly trivial, and I won't even really bother to prove it. Of course, it will have as its domain the set of all sentences, and of course, it will have as its range the set TF. So the domain and range condition for being a truth assignment is trivial. And it will respect connectives, which is fairly easy to prove. You could do a proof by induction, perhaps. But it's clear enough just immediately from the definition that this will be a truth assignment. So the only thing that even somewhat deserves a proof is the uniqueness part. And in particular, the way that I'm going to prove uniqueness is, I have here a particular construction of one truth assignment, which I'm going to consistently call V throughout. So V will always be the truth assignment constructed in the way that I just described. And what I'm then going to prove is that if you take any other truth assignment, call it W, which also extends V naught, V sub 0, I'll prove that V must equal W. Keep in mind, what does it mean for V to equal W when these are functions? I'm stating the equality of functions. Therefore, I am claiming that an input to these functions must result in the same output for each of the functions. So in particular, if you fix any sentence theta, then we must have V of theta equals W of theta. And that is true for all possible choices of theta. So that's what it is for these two functions to be equal functions. I will prove the equality of V and W by induction on the complexity of sentences. So that means that I'm going to prove this as a statement about the set of all sentences. Namely, I'm going to say that the set of all sentences has the property that, or any sentence has the property that this equation is true for those sentences, right? So effectively, just to be explicit about this, the property that this proof is going to be about for all sentences X is that V of X equals W of X, right? So this is the property, and it's a property of sentences. I'm going to claim and prove by induction on complexity that every sentence has this property. So we start from the atomic sentences, and that is fairly trivial because we are assuming that each of these is an extension of V naught, and therefore, if you take any atomic sentence, the value that V has on an atomic sentence is the same as what V naught has. Well, the same is true for W. So effectively, we just have this intermediary that V of this sentence, because it is atomic, is the same thing as V naught on that sentence, which then, because W also is an extension of V naught by our assumptions, then W has the same value, right? So basically, by going through the intermediary of V naught, we have that these are equal. Next, we'll do the preserves connectives part, which is to say the inductive part, basically. We will assume that, that theta is some sentence that has this property, and we will prove that negation theta also has this property. So this will be preserving negations. If we have a sentence, theta, which has this property, it must mean that V and W agree on the value assigned to theta, right? V of theta equals W of theta. Well, we want to prove that V of negation theta equals W of negation theta, and that's fairly trivial. For complete proof, you consider two cases. One where V of theta is equal to true, in which case V of negation theta is equal to false. And then you basically say the same thing all over again for W, and then you see that the two functions agree with each other on negation theta. You can then play the same game for any of the other connectives. It'll go almost exactly the same way. So that would complete the proof by induction, and we can move on.